Hello! G'day. Welcome to, another revision stream. So it's been about a month since the last one, and tomorrow we have a biology exam, so I thought perfect time to go and revise using some exam questions. So I'm gonna revise today, because I have a feeling that we'll get at least one or two questions on it. The tests for just about everything, really. Especially the emulsion test for lipids. We need to know what emulsion is, which I'm pretty sure it's like a white precipitate, but I know that's not what it actually is. It's like small bits of small like particles or something. Anyways, I'll go to the AQA website. Biology. In fact, I could probably go to Physics Math Tutor instead, because they have good exam questions for A-level. Yeah. Biological molecules. Alright. So we'll do carbohydrates, lipids, and then I don't know if she said proteins or not. I think she did. You know what? We'll do these three, okay? So that's carbohydrates, lipids, proteins, and enzymes. All right. Let's do this. So, monomers and polymers in it, basically. Okay. So, for context, usually when I do these streams, I this is a thing, right, with these streams. I always pick the worst time to do it. So if I need to go AFK for like 5-10 minutes, AFK as if I'm bloody playing Minecraft. If I need to go, that'll be why. So, no idea how quick we'll get through these. Anyway, so I might as well draw them on the board. Please excuse my terrible drawings. Oh, hello, Alex. Hello. I was like, I wonder who says in it. Okay. So I'm literally just gonna go through some like past paper stuff. I think most of these are probably on the question paper anyways, the one that we've been given as like revisions. So, yeah. Okay, these are the questions that I hope we get, little like matchup ones. I mean, this one does contain a question about DNA, which I know we're obviously not going to get, but we might as well do it anyways. Random Donny. Okay. Let me just go quickly check. Beta glucose is the one with the OH on the top. Yeah, okay. Just thought I'd quickly make sure I'm not like hallucinating stuff there. So it's again, I can't draw for shit here. So please apologize. Well, please apologize. That's gonna be alpha glucose. It is I'm assuming just a protein. I probably don't need to draw these actually. I'm assuming I can just write. One of them's alpha glucose, one is beta glucose, one is just a generic protein, and the other is a sort of a nucleotide. Okay, I'll just put DNA so I don't forget. So Which one is a monomer in an enzyme's active site? That would probably be the protein, because enzymes are made out of proteins. So I'll just put... is a monomer in cellulose, that would be beta-glucose. That one's relatively easy. Is produced during photosynthesis and respiration, alpha-glucose. Right? Or am I... Hang on. No, that's right, isn't it? I'm trying to think... No, hang on. What am I on about? No, it's not. I'm thinking about what's used during photosynthesis. What's produced during photosynthesis and respiration's... Like... maybe you would... Maybe protein? Because ATP... Is ATP a protein? It is, I'm like 90% sure. Okay, that's a bit of a tricky question, actually. That's worded really weirdly. Because obviously, photosynthesis and respiration both make energy. But also... Okay, we'll check the Mark scheme in a sec. Forms a polymer that gives a positive result with a Bayou-Rare test. I forget which one the Bayou-Rare test is. I could have sworn it was for proteins, but it's not. Oh, it is for Wait, what? Wait, so... Was Miss getting it confused yesterday? Because literally yesterday, she was asking a question about carbohydrates, and she mentioned the Bayou-Rare test, but that's obviously not possible. Alright, I'm going to swap around my answers here. I'm going to say that's 3. Yeah, I was going to say it. Bayou-Rare test is for proteins, because it goes purple if proteins. Let's check. Let's check the Mark scheme. Okay, those two are right. Produced during photosynthesis and respiration is C, which is... Oh, that's not DNA. I'm so silly. That's ATP. The only thing I looked at the diagram, I looked at it, saw ribose, and thought, okay, that's no. Need to pay more attention to the diagrams. Hello. Sorry. Oi, idiot. What? Chat, by the way, I get this tiny little box to see. So, apologies if I don't read your message. It's literally like this size. My camera's also inverted, so like... Shut up. Okay, that's a good little thing to recall then. Pay attention to the diagrams, because, yeah, clearly I would have gotten that one wrong. But I got everything else right, okay. Alright. Let's try find some more annoying ones, shall we? Some more annoying ones. Oh, okay, great. I read this one. I've read this one and I'm crying. Raffinose is a trisaccharide of 3 monosaccharides. Galactose, glucose, and fructose. The chemical formula of these monosaccharides are, and then it's telling you how many carbon atoms, hydrogen atoms, and oxygen. Raffinose is a trisaccharide, so it's made up of galactose, which is H12O6. Wait, they're all made up of... Oh, because they're isomers, aren't they? So it's made up of these. It's made up of these, the same thing 3 times. And it's asking you how many carbon atoms, hydrogen atoms, and oxygen atoms are there. So wouldn't you just add them all together? If it's a trisaccharide, surely it would just be... this is gonna be wrong. I know it is. But logically that would make the most sense if it's a trisaccharide. If it's all 3 of them bonded together. I don't know, that's a weird one. That is a very weird one. I'm kind of baffled here. Do any of you have an idea as to what... Are you meant to, like, draw a diagram or something to convey it? Like, I don't know, because... I don't know, carbon can only bond with 4 things. So would you, like... I don't know. I have no idea. I have no idea. That is certainly baffling. Let's check the mark scheme, which I'm sure is going to be very helpful. Okay, I got it wrong, but I have no idea why. That is a goofy one. C18, yeah, H32, and O16. What? How did they lose 2 things? Okay, if we get a question like that, I have no idea how you were meant to figure that one out. Where are they pulling it from? If that's 18, that's... I don't know, how did they lose 2 oxygen and 4 hydrogen? That literally makes no sense. My only thought no, because that can't be right either. No. Unless you're meant to make them, like... I don't know, we'll move on. I mean, look, it was a 1 mark question, but, like, you know, why make a 1 mark question that, like, pisses the hell out of you? Why the hell, bro? That's on the first page too. What the fuck? A biochemical test for reducing sugars produces a negative result. So reducing sugar. I'll just write that so I don't forget. Describe a biochemical test to show that raffinose contains a non-reducing. For free you've been on previous streams? Oh, okay. Describe a biochemical test to show that raffinose contains a non-reducing sugar. I'm gonna be completely honest here. Which one is non-reducing? That's the one where you hydrolyze, neutralize, and then do the Benedict's test. I think. Am I getting that wrong? That is what you do, right? Because that's the thing that we did in the practical. You add, what is it, like hydrochloric acid to break the glycosidic bonds. Now that it has a high pH because of the acid, you neutralize it. And then now that it's, I guess, reducing, you do the Benedict's test. I'm more clueless than you are. Okay, let's check the mark scheme. Oh, I was right. Okay. Heat with acid and neutralize. Okay, so 1 mark for both of those. Alright, great. I guess I'll go fuck myself. It also says heat with acid. I guess that kind of makes sense. Put it in a water bath. Obviously, in an exam, I wouldn't write this. I would put it into, obviously, more detail. So, I guess in a water bath, use... It doesn't even say hydrolyze. Like, you need to add acid. So I guess you can make things a little easier on yourself. Yeah, boil water bath for heat. You don't even need to put the name of acids or alkali. You can literally just say, heat with acid and neutralize for a mark. Alright, that's nice. Heat with acid and neutralize. Heat with Benedict's solution. I mean, that's, yeah. And then, yeah, you'd have to give a positive result. A red precipitate or orange. Somewhere on that spectrum. Honestly, for 3 marks, that was a nice one. If that came up, I'd be happy. Because, I mean, that seemed easy. Like, that was fine. Even if... I probably would have gotten just 2 marks alone for that and that. Benedict's test... hydrolyzing, neutralizing. I guess you always need to make sure to mention the water bath. And then a positive result as well. Oh, great. In fact, I've done these on a previous stream. So you know what we'll do? We'll skip ahead to... What the fuck? Okay, hang on. Hang on a minute. I've seen some nasty-ass terminology here. Okay. What is a monomer? Okay, that's obviously an easy one. I guess you could say, like, what? Small repeating subunits from which larger molecules are made. I guess larger molecules could refer to polymers. Let's just check, make sure I'm not, like... A monomer is a smaller repeating unit from which larger molecules are made. Okay, great. That was an easy mark. What the hell is this? Lactulose is a disaccharide formed from 1 molecule of galactose, 1 molecule of fructose. Other than both being disaccharides, give one difference between lactulose and lactose. Okay. Lactose is galactose and glucose. And what's it called? Lactulose is obviously, as the description suggested, galactose and fructose. That's an easy 1 mark there. This is out of how many marks? 2. Alright, so that's a similar difference. They are both... What? Like, could you literally just say they're both polymers? Like... not polymers. They're both disaccharides? Could you literally say that? Or is that, like, cheesing the question? I feel like that's cheesing the question. Ah, okay, it's not the mark scheme. Both contain galactose. Well, no shit they do. Okay, but really? You'd literally just get a mark for saying, oh, they both contain... Bruh. Okay. Thank you, QA. And they both have glycosidic bonds. Alright, well, yeah, no shit. Lactose contains fruit. Okay, yeah. Well, that was an easy one, but you could very easily... You know, that's the thing. Sometimes with AQA, they'll ask you a question, and if you overthink it, you'll get it wrong. Other times, if you underthink it, like, you need to try find that, like, balance. It's annoying. Glycogen and cellulose are both carbohydrates. Describe 2 differences between the structure of cellulose and... Okay, this is a nice one. Actual nice question. Describe 2 differences. Alright, well, you could say one, obviously, cellulose is beta glucose, and glycogen is alpha glucose. That's a very easy one. Well, they're made up of, I guess you should say. I don't know if it's a better word than made up of that you could put. I guess we'll find out in a minute. And then the other difference, I guess you could say that glycogen is branched. And obviously cellulose are in straight chains. Long and branched. I'm assuming these are long and unbranched. Short and branched. I guess that's literally what you'd say, no? Cellulose is made up of beta-glucose monomers and glycogen. Okay, yeah, easy. Cellulose has a straight chain. Glycogen is branched. You could also mention the fact that glycogen has one 1,4 and 1,6 bonds. Cellulose only has 1,4. I mean, that makes sense, because obviously on a, what do you call it? On a thing like that, it'd be that one and that one. And then 1 and 6, wherever 6 would be. That makes sense. That does make sense. Okay. Some very easy questions here, actually, now that we've gotten over the hill. Starch is a carbohydrate stored in plants. Describe two features that make it good storage. That is lovely. It's insoluble in insoluble in water, meaning that there is no osmosis. I'm sure there's a better way of saying it, but that's what it is. And then it's a large molecule, so it can't, like, I don't know, it can't be moved. What's the thing that she put in the mark scheme? It is large molecule. Oh, so it can't move across the cell membrane. Okay. It is insoluble, so no water. Yeah, that's it. That's the word I forgot. Water potential. Oh, you could have literally just said that it's compact. Oh, wow. Bro, honestly, 4 marks there. That is beautiful. Tick the box that identifies the... Bro, these are beautiful. The box that identifies the test, which would be used to show the presence of starch. The iodine potassium iodide test. Lovely. 5 marks. And what? We have maybe 60 minutes to do this exam tomorrow. If there's 50 marks? That's 10% of a paper that you could get without even revising. Lovely. Oh, shit. In mammals, the early stages of pregnancy, a developing embryo exchanges substances with its mother via cells in the lining of the uterus. At this stage, there is a high concentration of glycogen. Oh, okay, describe the structure of glycogen. Alright. They went on a bit of a rant about pregnancy there. Describe the structure. I guess you could say that it's small. It has branches. It's like branched, allowing for... Oh, no. Okay, hang on. This is too good. 4 marks again. Suggest how glycogen acts as a source of energy. The coils allow... what is it? Just enzymes to easily hydrolyze, to release energy, to hydrolyze the glucose. That is a lovely one, is it not? Okay, that first question that I said, you would have to refer to it being alpha glucose. Okay, so I guess a note to make, if it's asking you about structure, talk about obviously its monomers. If it's asking about structure, refer to monomers. Ah. Oh shit. Okay, this is a very tricky mark scheme. For the other question, you have to say that it's hydrolyzed into glucose and that the glucose is used in respiration for energy. You're not allowed to just say that, you have to go a step further because it's asking about energy storage. So you'd have to refer to the fact that it uses energy. Interesting. Okay. Those are some nice ones, but I feel like I would have only gotten 2 out of 4 there because I didn't include enough detail. Anyways, name the monomers from which a maltose molecule is made. Shit. That is fructose and glucose? It's glucose and glucose. I swear it is. Yes, it is. I almost fell for my own trick. Glucose and glucose is maltose. Glucose and fructose is sucrose. Glucose and galactose is lactose. Name a type of chemical bond that joins 2 monomers to form maltose, glycosidic. There we go. A student wanted to produce a dilution series of maltose solution, so he could plot a calibration curve. Math questions. Concentration of maltose solution. Volume. No idea what you would do for that one. That one is tricky. Complete the table by giving all headings units. No idea. You'd have to draw a line of best fit in a graph. I mean, that one would be easy. Explain how you'd use a graph. I mean, yeah, okay. Honestly, there's some tricky questions here. There's this one, which I always get wrong. It shows you an image of starch and the fact that it's bonded like that. I guess cellulose, you'd have to say that it has an inverted pattern of bonds. Let me check the mark scheme here, because I know. Yeah, inverted. Starch formed from alpha glucose, but oh really? You could just say that. Starch was formed from alpha glucose, cellulose from beta. Position of hydrogen and hydroxyl groups are inverted. Alright, that's a very easy one. Just talk about it being inverted and what it's made up of. Alright, well there you go. That is the carbohydrate stuff. Let's move on to lipids. Lipids, I think, are probably the easiest, but the most tricky in an exam. The general structure of a fatty acid is RCOOH. Name the group represented by COOH. That would be is it a carboxyl group? Or would you have to say carboxylic acid? Yeah, you can just say carboxyl. Name the type of R group shown in figure 1. Does it look like I know? Shows a fatty acid R group. Oh, it's unsaturated. Oh, mono unsaturated. It only has 1 carbon bond. Oh, come on, you could just say it's unsaturated. Oh, piss off, Hitler. I went into that extra detail. Yeah, it's unsaturated because while it has only 1 carbon, it has a double carbon bond, so it can't reach. It is not at its max amount of hydrogen. Yeah, double bond between the carbon. You could also just say that it's an alkene. That's cool. Describe how you would test for the presence of lipid in liquid sample of food. Alright. Add ethanol. Add water. Shake and mix. And a white milky emulsion is what appears. Okay, we need to recall this. We need to remember this. So you add ethanol. You add, I'm assuming it's distilled water. Yeah, add water. Shake and mix. Shake and mix, and a white and milky emulsion. Indicates a positive result. That is important to remember, because I'll be honest, I did not recall that. Describe how a triglyceride molecule is formed. Oh shit, I have no idea. How are they formed? Well, obviously you have a glycerol backbone. You have your free fatty acid saturated fatty acid chains, and these are ester bonds. Now, I'm going to interpret that obviously it's a condensation reaction. So a condensation reaction joins three saturated fatty acid chains to a glycerol backbone, forming ester bonds between each chain and the backbone. No idea. That's my guess. 1 glycerol and 3 fatty acid. Condensation reaction. Oh, okay, you would have had to elaborate that condensation involves the removal of 3... Okay. And the ester bonds are formed. Alright, I would have gotten 2 marks there. That's great, because I had no idea what the question was asking. I would have gotten 2 marks. Holy shit. Caprylic acid is an unsaturated fatty acid represented by diagram L. Well, which one? Caprylic acid. Well, it has 0 double bonds, so it has to be saturated. It has to be saturated because it has no double bonds, and yet here it's saying it's actually the other way around. Why? Oh, wrong one. It's palomietric. And you can see by diagram K because it has a line on it. Okay, no, I would have got that one right. I just misread the question. Describe how a ester bond is formed in a phospholipid molecule. Wouldn't it literally be the same thing? Condensation reaction uses, would it be 3 water molecules? Or 2? I'm going to say 2. Uses 2 water molecules to create ester bonds between the saturated and the unsaturated. No, it would be 3 because then you have a phosphor diester bond, but... No, it would be... I don't know, hang on. Condensation reaction between the glycerol... Oh, that's what you'd get. Condensation reaction between glycerol and fatty acid. That's all you'd have to put? But I went into extra detail there, and you didn't give me any marks. Fuck you. Oh, the diagram represents a triglyceride. Name the molecules. Okay, well that would be glycerol, and that would be fatty acid. Is that what you'd have to put? Yeah, glycerol and fatty acid. Easy 2 marks. Name the type of bond between P and Q. Oh, I love that song by Keno, P's and Q's. Ester bonds. Alright, we get to do another test for lipids, and this one is 2 marks. Alright, so it looks like it's always 2 marks. So you'd add your ethanol, add your water to the liquid sample of food. You'd obviously shake it and mix, and a positive result would be if a white or milky precipitate, no, not precipitate, emulsion is formed. There we go. Yeah, you're not allowed to say precipitate. Describe how you would test a piece of food for the presence of a lipid. Same question. That seems like it could be a very common question then. So you add ethanol, you add water, you shake it and mix, white emulsion. Okay, an interesting one here. The figure shows a phospholipid. It literally takes up a whole page here. The part of a phospholipid labelled A is formed from a particular molecule. Part labelled A is formed from a particular molecule. What does that mean? It's showing the glycerol backbone. That's what it's showing. It's formed from what? I don't get it. Glycerol. That's all you would have had to say. Bruh, are you taking the piss? Okay, well that's obvious. Okay. It's worded awfully there, to be fair. Formed from a particular molecule. Oh, no, I get it. Because it's saying this whole phospholipid is made up of some stuff, including okay. Name the type of bond between A and X. It's probably an ester bond. Which of the fatty acids, X or Y, is unsaturated? It would be... It would be the second one. Why? Because that one only has a CH bond instead of a CH2 bond. Oh, you would have had to explain why. Contains double bond between adjacent carbon atoms in the hydrocarbon. Well, that's not what I put. No, I'm an idiot. It's even more simpler than that. It literally in the diagram shows a double bond. A double bond between the C... Okay, easy. Scientists investigated the percentages of different types of lipid in plasma membranes. The scientists expressed their results as a percentage of lipid. Explain how they would find these values. You would probably use self-fractionation, would you not? Oh no, it's even easier. Divide the mass of each lipid by the total mass of all lipids. Fuck, what? That is easy as shit, but I overthought it. Okay. Well, that's every lipid question. So guys, seems like there could be very easily some questions based on the test. The diagram shows a primary structure of a part of a polypeptide. Each shape represents an amino acid. Name the type of diagram of peptidase which would hydrolyze the bond labeled G. What the hell does that mean? Endopeptides. No idea what that would have meant. Give the diagram of different R groups shown. Would it be 3? Because there's 3 unique... Yeah. A scientist used an enzyme to digest a polypeptide containing 101 amino acids. With a digestion produce a range of smaller polypeptides. Use the information in the table to calculate the number of polypeptides. Would it be... Hang on. Use the information in the table above to calculate. So it goes from 5 to 2. So it'll be you divide by 5 times by 2. Calculate the number of polypeptides. No idea. If it goes from 5, number of amino acids in the polypeptide. Would you do something like divide by 101 or some shit? Two amino acids in length would have a number of 2. No idea how you would even answer this one. Describe the induced model of fit. Okay, that's easy. No, it's not. Hang on. The substrate binds to the active site. An enzyme substrate complex forms. The active site changes shape, so it's complementary. And it reduces activation energy. Okay, well, guys, that's where I'm wrapping things up for now. We've done a lot there. So, a couple things to remember. If it's asking you about the structure and it's a carbohydrate, talk about alpha and beta glucose. This will probably appear in the exam, the test for lipids, some other things. Look at the diagrams carefully. Don't overthink them. What else? I mean, just try and go into as much detail, but not too much, I guess. I guess for the practical ones, just make sure to include as much detail. You know, mention acid, heating, things like that. Anyways, I'm done. That's all the revision that I'm going to do for now. I will probably do some more later, but I won't stream it. I know no one's watching now, but if you guys do end up watching this to revise, let me know how you feel about the exam and if you're looking forward to it. Yeah, thanks for watching.